Let's focus on the task of image captioning. Again, the video for that is online. Last year, we spent a lot of time on it, going into a lot of details. But in terms of the big picture, you have an image, and then you want to generate the corresponding caption for it. We know that the caption is going to end up being a sequence of words, and each word you're going to represent by integers. So it's going to be a sequence of integers. If you're outputting something, if you're looking for what word to be output in the first location, you're going to output a probability distribution on it. And if that word is the input to your network, you're going to represent that by one-hot vectors. So when it comes to output, these are going to be probabilities over all the possible words that could happen. The size of it is going to end up being the size of your vocabulary. And when it comes to input, these are going to be one-hot vectors that you're going to embed in a low-dimensional vector representation. So that part we know. But how are you going to include the image? If you remember, we had the same problem when we were doing translation. We had an English sentence. You would encode it in a single vector, and then you take that vectorized sentence, put it as input to the decoder, which is going to output the French translation. Now what you're doing is translating an image to a sentence, an image to an English sentence. And all you need to do is vectorize your image. And the way that you're going to vectorize it is using the convolutional neural net. And don't worry about this architecture. This is the inception architecture from Google. It's GoogleNet. And we covered that in part 1 of the course. We spent a lot of time designing CNNs over there. But once you do that, your problem is solved. You have an image, you vectorize it. That's going to be the first input to the LSTM unit at the first element of your sequence. And then the rest of them are going to get generated. If you want to generate the next word, maybe you just generated the beginning of a sentence. Actually, S0 is the beginning of the sentence. You take that, you embed it, you push it through LSTM in addition to your vectorized representation for your image. And then you're going to output the probability distribution over what word should be next. In this case, for instance, it could be A. Then you take A, you vectorize it, you push it as input to your LSTM in addition to the hidden information from the past. Then you're going to output the next word, which is going to be a person, which is the maximum probability one here. You take that, push it to the next unit, and then you keep continuing until you see the end of the sentence symbol. This is a naive way of decoding. There is actually better ways of doing decoding, like beam search. Rather than taking the maximum probability at each time step, you're going to pick perhaps 20 of them. And then you consider all 20 of them in the next stage. And then out of those two symbols, you're going to also multiply those probabilities together and pick the top 20. And then you keep doing that. And that's called beam search. And we were using beam search when we were doing generative language models. And we were using beam search when we were actually translating from one language to another one. Is everything clear about show and tell? Okay, perfect. And in terms of applications, one of them is helping visually impaired people. They're not going to see the image, but they're going to hear, and that's where speech is going to come in. We're going to do text to speech, and then they're going to hear that a person is riding a motorcycle on a dirt road. And then they can imagine what is happening in that image. Another one is actually understanding what the neural network is thinking about. And another one, this is really interesting. For instance, this one, you're going to understand why the neural network is making that mistake. Because on our refrigerators, we usually fill them with lots of stuff, lots of stickers. On this road sign, there's a lot of stickers. And then the network is saying, this is a refrigerator filled with a lot of foods and drinks. And once you know that, then you can start thinking about new architectures to avoid those sorts of mistakes, or perhaps remove this data, or perhaps show it more of this type of data. And actually, another application is building trust in your AI system. Let's say you're sitting in a self-driving car, and then the car has a screen in front of you, and it's explaining what it is seeing. And then as soon as a mistake like this happens, a human can intervene. So it's not going to be full self-driving car, but there is going to be some human intervention. Okay, if there are no questions about show and tell, and the algorithm here is called NIC, Neural Image Caption. If there are no questions, I can move on.